Hello. Don't tell anybody, but I'm about to tell you a big secret. And keep it a secret because it's got to be worth a lot of money. It's called logarithmic differentiation. And I'm following James Stewart's 6th edition calculus textbook. I'm on the asterisk section of this chapter. I've already done this video already. I'm going to do it again, though, for those of you following the asterisk version. Now, here's the problem. Sometimes you have something really complicated, a really complicated function. And some torturer of a calculus teacher says, you will take the derivative of this function. Let's say that number 61 in 7(2) asterisk asked you to find the derivative of this monstrosity. Look at that. Doesn't that look horrible? I mean, I'm coming, Elizabeth. I'm having chest pains here just thinking about doing this. Let's see. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Wait a minute. These are multiplied together. The first times the derivative of the second plus the second times the derivative of the first. I mean, can you imagine how insane it would be to try to take the derivative of this thing just following the product and quotient rule, from way back in chapter 3? It would be insane to do something like that. Well, let me tell you about a little secret. Let me tell you about logarithmic differentiation. And it goes like this, and it's very easy. It's basically you take the logarithm of everything. You take the natural logarithm of everything. Take the natural logarithm of y, which happens to be the natural logarithm of y. You take the natural logarithm of this monstrosity, and look how it unfolds, just like a bloomin' onion at Outback Steakhouse. So the exponents all become coefficients, because that's the rules of logs, right? The rule of natural logs. I've done videos on these in this chapter. So the 2 comes out as a coefficient, the 4 comes out as a coefficient, the square comes out as a coefficient. That's so nice, it's so easy. And then you remember that when you have 2 things multiplied by each other, when you take the natural logarithm of them, they're just added together. Logarithm of sine of x plus logarithm of tangent of x. And then when it's in the denominator, you subtract it, minus the natural logarithm of x squared plus 1. Boy, that's easy. And I got all worked up. I soiled my alma. Look at this. It's so easy. Now I use implicit differentiation. I take the derivative of both sides. And so I know from a previous video I've done, the one right before this, that the derivative of the natural logarithm of y is 1 over y dy dx. If I take the derivative of this, it's going to be 1 over the sine of x, right? The 2 stays there. The derivative of the natural logarithm of sine of x is 1 over the sine of x times the derivative of sine of x, which is cosine of x. So that's mischief managed. If I take the derivative of tangent of x, the derivative of the natural logarithm of the tangent of x becomes 1 over tangent of x. And then I take the derivative of the tangent of x, which I've memorized from a previous location, that the derivative of the tangent of x is the secant squared x. And then here, when I take the derivative of the natural log of this, this goes, first of all, 1 over it. And then I take the derivative of it, which is 2 times x. And then 2 times 2 is 4x. Okay, this is so easy. Man, this looked like it was going to be so hard. I was going to spend days working on it. And look at how it just nicely peels away into something like this. Now let's do a little simplification. So let me multiply both sides by y, okay? And now I've got the derivative of this is y times, well, cosine over sine is cotangent, fine. I'm going to leave this the same. I'm going to leave this the same. Okay, now I'm going to substitute, what was y? Y was, well, this is y. So I'm going to plug this back in for y, and there's your answer. See how easy that is? Good grief. It looked so hard. I looked at this, my torturer said, take the derivative of it. And I looked at it and it just peels away. So easy. Logarithmic differentiation is spectacular, incredibly powerful tool. And you heard it here first on YouTube. Well, maybe you didn't. But what are the steps in logarithmic differentiation? First, take the natural logs of both sides of your complicated equation and use the properties of logs to simplify it. Then differentiate both sides implicitly with regard to x, and then solve for y prime, solve for the derivative. Simple as that. I mean, this is one of the most powerful tools, but don't tell anybody because we don't want the secret getting out.